1950s Motorola black and white console television for possible resurrection. We'll start this off just as an analysis. This will be the analysis video. This is pretty beat down. This is a beat down 1950s Motorola black and white television with disintegrating wood. Not even worthy as a dog cabinet. Oh yeah, look at this. Look at the wear. Ooh, someone did tic-tac-toe. I guess I could be nice and prop it up on a brick, couldn't I? There we go. There's to professionalism. Cabinet is in maybe fish tank condition. Let's see what we got here. Model 21K. Is that it? 21K. 21K1 something. Let's see here. Oh, nothing but the best. Look at that. We got a bodge job. Haven't even gotten the back off yet. I like this too. I like how they bent this fiberboard stuff to kind of tacky. Ooh, suburban, fringe, or local. What's the difference between suburban and local? Yeah, this is in pretty harsh condition. It's not quite abandoned desert dump condition, but it's pretty close. What I'm wondering is where are the controls on the front? Does it not have any? Is this all the controls? Was Motorola so sure of themselves that... Oh, yes. Boy, this is a beauty. She's a beauty. Where is my toolbox? Webs. Lots and lots of webs. I guess this is the rest of the cabinet. Take the chassis out and put it on Marketplace as a cigar lounge for your dog. Man, I sure do come across some poor quality junk. Jeez. Poor condition, not poor quality. I'm sure at one time this was fairly decent quality, but now it's just like baked. Well, the first task, the first item we have to do is check the picture tube, because if the picture tube is not capable of making a picture, then there's no reason to proceed. This is interesting. I think this is one of those hybrid kind of chassis where it uses a transformer for the filaments, but then it uses a direct line doubler circuit for the B plus. And speaking of that, I worked on one of these before that the flyback was disconnected. Where is the flyback in this? Where is it? Is it underneath? Here's a horizontal output. There's the damper. Where's the high voltage rectifier? Okay, Motorola, what the hell are you doing to me here? What is this right here? Why do we have a diaper on top of the CRT? It's also got some kind of weird built-in antenna up here on top. Well, that was terminated long ago, wasn't it? Guess that didn't work too well. This is really what you call crash and burn TV repair. This is the train wreck television resurrection channel. So, so we're gonna set the voltage first. So we'll go about 6 volts. I'm not too optimistic on this. Although I do see glowing there. I'm sure it would aggravate people that I don't clean that off, which is why I don't do it. I like it dirty. Okay, no shorts. No G1 shorts. Gun balance, which is the same as cutoff. And I don't know what our bias is supposed to be, so ABC, who knows. And I think I got the right, I think it's adapter number 1 on this. No surprise here. I really would like to know what the number of this CRT is. But there's no tube chart, there's nothing here. Come on, Motorola, get it together. It's got to be number 1. There's nothing else that would fit here. It's just the old school original. I'm on black and white. Black and white. I got this all the way up. Let's move this around. Okay. Let's go up on the voltage here a little bit. Let's see. We're at 6 volts there. Let's crank it up to about 7.5. Oh, we starting to get a little emissions. Look at that. This is a hot one. Oh boy, can't stand it. It's gonna be so bright we're gonna all be blinded by it. This thing is I think this is going to be, this thing is going straight to the cat tray department. It's coming up a little. I'll let it sit for a minute. So here's a little tip for anyone who does this. If you're going to cook a tube, don't leave it on the gun balance or cutoff or emissions test. Put it somewhere else so you're not just running current through the cathode, burning what little is left away. And then when you come back, then go to your gun balance. And all of a sudden we have cutoff now. See emissions. Wow. Now see this? See how it starts dropping? It's because I think it's burning what's left away. It's just baked. Let's come back down to around 6 volts. Let's see what we got here. I mean, maybe. Maybe we could get a picture out of it. I don't know. We should just do like the flea market thing and just plug it in and see what it does. Not even use any protection, just plug it in and just, yeah, bareback the hell out of it. Just wreck it. The only problem with doing that is it might cause more problems for me. Just plugging it in cold without any kind of, variac or light bulb might end up popping fuses or fusible resistors or something else, because the caps are shorted and need to be reformed. I think I'd rather just bring it up slow out of just being more lazy than anything, because I'd rather not just blow it up. If we have a chance to resurrect it, I mean, we pretty much know the drill. It's going to have vertical issues and probably horizontal issues and probably not work worth a crap, but we've done so many of these on this channel that we sort of know the drill. But anyway, I think there is a potential there with that picture tube. February 1965. So I'm trying to find the schematic for this, even though I probably don't need it. And remember, we had 21K, and then of course conveniently ripped off was the rest of it. So we have 21K, a whole bunch of different things here. So what we want to look for, I think, it goes all the way from 21K1. We need to look for this chassis number, and it looks like the chassis number is TS or WTS. Is that TC351? Do we think that's it? Okay, let me try for that. So that must be TS351. And TS351 is the 21K1. Let's see if I can, right there. See that? TS351. So it is a 21K1. So it's 173.9. I don't think I have that. Alright, well, out of an abundance of laziness, let's look at the riders, which I have these all in my phone. Looking on the desktop right now, but let's see, TS351. TS351, ooh, we have it. 10, whatever that is, 1012? 1013. So let's see here. 10. Well, what am I turco-quinculating here? So where is 10? Okay, here we go. I'm being simple. There's 3 DVDs here, and I think at this point the phone is probably faster than the desktop. Let's see, page 13. Isn't this fun, watching somebody scroll through crap on their computer? But this is what actually makes this stuff successful. 9, 11, 13. So here it is right here. Let's see. Ooh. Clerky Boimler Borgelblarfer. Okay, here we go. as if you could read this. I actually really like Sam's, I think, better because of the pictures. So this is interesting. Let's take a look at this real quick. TS325 and 326. 12AX4, 25BQ6. That's interesting. What do we got going on there? Where we got a mixture of 6 volt. Okay, this has got a 6BQ6. We had a TS351, correct? So this uses all 6 volt tubes. Same thing with the high voltage lead going underneath. Ooh, selenium rectifiers. Oh, look at the high voltage rectifier is underneath the chassis. The flyback and high voltage rectifier underneath the chassis. You so cool, Motorola. You so cutting edge. You lit. All right, where's the schematic? All right, this is part of the video is exceedingly annoying, I think. This is TS325, 326, and you can see this is series string right here. Wow, look at this with some resistors like bridging randomly the filaments to get the right current match. Look at how this is done with these in series parallel with this, and then series parallel with a resistor, series parallel with a resistor. Geez, Motorola, you so cool. And then this is the one we're working on right here, which, like I said, it's hybrid. So it uses a power transformer for the filaments. And I'm sure there's a reason why they did this. And then it uses a doubler for the line voltage. So your line voltage, and this is the fusible resistor right here that I don't want to blow up by just plugging it in. 12AX4, which is pretty interesting. I guess the damper has its own winding on the, and they probably float this voltage up. They probably float that voltage up close to B+. 6BQ6, which is cool. And this is all underneath. Does this tell us what our CRT is? I don't think so. I think it can have different CRTs depending on the model. That's how these sets were. So anyway, it's page 536 of volume 10. I won't remember that, but I'll pretend like I do. There's nothing else. Vertical output 12BH7. All these capacitors are going to be twacked in here. This is interesting. This doesn't even have a capacitor between the plate and the grid. How are they doing that? I guess they're floating this way high. They're floating the cathode way high. And then they're using a autoformer to drive the yoke. Motorola really thought they had something going on, didn't they? Block oscillator. All right, well, this is going to be an interesting one. While we're looking at this, let's go back, and we got two 200 microfarads here. We got a 100 microfarad doubler. We got 140 in series, and we got 100. So we got 140, 100, 200, 200 as far as our filters. Just want to try, but this is real fancy ass circuitry. This is really one ugly ass TV. I mean, I guess it's all beauty. Beauty is in the eye of the beholder, and I ain't beholding this thing. I don't know. To me, I don't like it. It has Marlboro virus. Definitely, if somebody watching this is turned on by this and would like to adopt it, please get it out of here as quick as possible so I don't have to look at it any longer. Because, I mean, not only it's not that it's dirty and needs to be polished, because the cabinet is really not in that bad a condition. I mean, it would straighten right out. I don't like the bezel. I don't like the fact that it sticks out, that it's bulging out of the cabinet. I don't know, it's just not my style. But let's see if we can get it to work. Let's put it on a dim bulb, and I'm just going to give it 2 or 3 hours to reform. I'm in no hurry. Starting off with 68 watt, and it's like almost full brightness. And what I'm doing is I'm measuring the voltage. I got the plate cap on the horizontal output disconnected. I'm going to measure that for a while. And that won't start to come up until we get the damper tube lid off. I would think it would come up a little bit. It's almost like, yeah. I believe this is that sand resistor right here that I talked about, that fusible resistor that's right in line with the AC line. So if I measure here on AC volts, I get 51 volts. Keep in mind I'm going through a light bulb, 49 volts. If I measure on the other side of it, I get, well, 49 volts. I was thinking this thing had Marlboro virus. Well, now I have 87 volts on the plate cap there. So maybe I was just getting impatient. All right, we'll just let it sit for a while. No hurry. Let's see if there's any AC here. Not much. So is that about double what we had on the sand resistor? About. Just let this sit for a while, like an hour. I think it's been an hour. We've come up to 95 volts on the plate cap of the horizontal output tube. Let's go up to a 150 watt, well, essentially double. No, you don't fall off and break. What kind of light bulb is this? It's a traffic bulb. 15,000 hours. Hundred and climbing. Nice. We got B+, and I can start to see the vacuum bulbs glowing. Oh yes. Nothing from the speaker. If this is the channel selector, there's absolutely no detents left. It's so damn worn out. I mean, this thing is just worn the hell out. Maybe there's a little detent there, but yeah, I mean, that's almost free spinning. I'm going to try an experiment. Since this is so dim, I'm going to hit the bypass switch here. Okay. Let's hook the milliamp meter up between... Well, we've got about 35 milliamps draw on the plate. It's kind of low, but you know, we're at half voltage right now. Just let it, I'm going to disconnect this and we'll let it bake for a little while longer. The odds of this thing working is so damn low. Alright, let's see what kind of trouble we can get into here. the thing has been on the light bulb now for several hours and no further improvement. So we'll hook this up. This will give us our, if I could, 30 milliamps. I'm gonna hit the bypass switch on the light bulb. I wonder if, ooh, that was an interesting, God, I can swear I can hear the, it's with the mic gain cranked all the way up. No audio. We do not have excessive plate current here at all. In fact, it's kind of low. Well, there's actually a little bit of high voltage there, 5K. Well, that was good. In fact, that was award-winning right there. I'll try this at home, kids. This is how I make suicide. This is not real bright. Well, it's interesting, that noise sounds like it's related to the horizontal. Maybe the horizontal frequency is way... Ooh. I think we got ourselves a synthesizer here. Oh yeah. Oh yeah, that's a... This is what happens when you get a bunch of leaky capacitors. There we go. Getting the frequency up, we're getting the high voltage up. So that's tweaking on horizontal hold and horizontal size. Let's make sure the brightness is all the way up. Oh yeah, there we go. And of course, just as I suspected, the vertical is dead. Well, look at that. You got your first light. And this thing is screaming loud, man. You could probably hear this for a couple 100 feet. It's so loud. Well, there is some hope. These are our vertical. Frozen. Wow, that's hot. Is that thing gone to air? That thing might be gone to air. See that? That's a white cap. Talk to me, Daddy. I think that one's gone to air. Okay, the tube that's white capped or gone to air is this one right here. 6W6, and that's the audio output tube, and that actually makes a big difference, and I'll show you why. Let me see, V210, V210 audio output. I'll show you why that makes a big difference. On this set, and a lot of sets of this era, the audio output is used as a voltage divider. So we have 265 on the plate, and then we have one at 155 on the cathode, and that is used to power a lot of the other circuits. So what I'm doing is I'm following this red yellow, I'm following this wire down, so that comes over to, sorry for the crappy video here, that comes over to here, and that powers all of the IF. Okay, red yellow, and that comes down, red yellow comes down to the cathode of the picture tube. Yes, it comes to the brightness control. So without this voltage, a lot of stuff is going to be missing, but it powers all the audio, it powers all the IF. So without the audio output tube in place, none of that's going to work. But the vertical, let's see where the vertical gets its voltage from. This is a weird vertical circuit. So the vertical is 240 volts. It gets that from okay, this is 480. Okay, so that's it gets it. Why do we have 280 over here on this here standby? So this is a bit of a trip. So the high voltage is supposed to be 14.5K, and we were barely getting 8. And the plate, this Motorola, so this is B plus right here. About 250 volts straight out of the rectifier doubler circuit. Then over here, I don't know why they give a measurement here. That would fry your meter, but 480 volts, and it's coming down through here, and I would think this is like a boosted off the horizontal output. And then I guess they're saying that's 280 there, and then that feeds the vertical deflection. Which feeds the center tap of the yoke, which feeds the autoformer, which feeds the plate of the vertical output. And this is Motorola. Weirdness. So 5,000 picofarads would be 0.005. 47,000 would be 0.047. We're not used to, we don't really do things with these kind of numbers anymore. The SAMs would certainly be nice for this, because the SAMs would probably, see, they show it over here 0.005, which I believe that's 5,000, and then over here they show it as 5,000. So I don't know if that's a mica or what. I don't know why they're designating some of them 10,000. So that would be what, 0.01, and then over here they 0.005. So I don't quite get it. But anyway, we got vertical issues. We always have vertical issues with these old TVs. If you ever work on one of these old 50 sets, you're going to struggle with the vertical circuit. It's just going to happen. They're very difficult. So we should probably check like this right here, this 0.15, you know, and this 5,000. We should see what kind of capacitors these are. I don't know what Motorola's doing here, besides confusing the hell out of me. I think I'm going to wrap this here. Tomorrow I'll pull the chassis out and we'll get it on the bench. I think we got a good analysis here. We kind of know what's up. I mean, we got a good foundation to work from. We got a semi-working CRT and semi-working high voltage, and assuming we can get the vertical working and nothing like the yoke or anything like that's bad, I think we can make picture on this UGMO. So I'll wrap this one right here, and in the future sometime we'll see a picture on this in part 2.